Hey, this is Adrian Rosebrock from PyImageSearch.com, and today we are going to install OpenCV 3 on Raspbian Stretch. Let's get to work. Hello and welcome to this PyImageSearch tutorial where we'll be installing OpenCV on your Raspberry Pi running Raspbian Stretch. As you can see, I have the URL of the blog post and tutorial pulled up in my browser. If you're viewing this video on YouTube, just click the description and you'll be able to copy and paste a link directly into your browser and follow along with us. You want to make sure that you have these instructions pulled up because we'll be doing a fair amount of copying and pasting some commands and looking at the output. So take a second now, get the pause the video, get the URL pulled up in your browser, and when you're ready, let's continue. So I recommend starting off installing OpenCV 3 on your Pi with a brand new install of Raspbian Stretch. I don't recommend trying to upgrade an existing Jessie install. There's just a lot of things that could go wrong, a lot of problems you might run into. Just make sure you go and grab the latest copy of Raspbian Stretch and download it to your system. So if we just go to the Raspberry Pi website, to the downloads, you can click on Raspbian and then download the zip file. Then you can flash it to your card and boot it up. So I'm going to go ahead and log into my Raspberry Pi. I'm going to use SSH to log into it over the network. You could also use VNC, that's perfectly acceptable. Or if you just want to hook up a keyboard and a mouse and a monitor, do that too. You know, whatever is easiest for you. I personally like SSH because I can run the Pi in headless mode. I don't need a monitor, I don't need all the peripherals. Just command line is all we'll need for this. So once you are logged into your Pi, I recommend launching the Raspberry Pi config command and going into advanced options and expand file system. This is supposed to happen automatically on boot for the first time on Raspbian Stretch, but just in case it doesn't, you'll want to go ahead and reboot your system. So I get a message here saying the root partition has resized and we need to reboot. So we'll say, okay, go down to finish and say, yep, let's go ahead and reboot now. So as you can see, the connection to my Pi has been closed. My Pi is in the process of rebooting, and once it's booted back up, we'll be able to see that we're using the full Raspberry Pi file system. All right, so my Raspberry Pi is all done rebooting. I'm going to go ahead and log back into it, and let's take a look at the output of the df command. This will give us some insight into how much space we have on our Raspberry Pi. So I have a 16 gigabyte card with 3.4 gigabytes used and 11 gigabytes available. If you're running low on space, I actually suggest that you run these optional commands. This first one will remove the Wolfram engine, and this one will remove LibreOffice from your system. This will allow you to reclaim about a gigabyte of space. So if you're running short on space on your card, definitely use these commands, but again, they're totally optional. So now we're ready to move on to step number 2. This is where we install our dependencies and get our system configured for the OpenCV build. This command right here updates our package definitions and then also upgrades any existing packages that are already installed on our system. So again, this command is responsible for going out and fetching the package updates. And once we have all the package updates, the definitions of the updates, they can be applied via the upgrade command. This will take a few seconds to actually go through and download the update. And then once you get to the upgrade point, it'll prompt you and say, do you wish to continue? Just select yes, and let your Raspberry Pi go ahead with the upgrade. Again, this will take a minute or two, not very computationally expensive, also just a little network overhead as you download the files. Once this is done downloading and installing, I'll check in with you. Welcome back. My Raspberry Pi has went ahead and updated and upgraded, so we can move on to installing our developer tools. Just copy and paste the command in here and let it run. This command is responsible for installing, again, all of our developer tools related to compiling OpenCV, CMake, make all of the build configurations. rely on these packages to make sure they're installed correctly. Similarly, we also need some I/O packages specifically for reading various image file formats from disk. These libraries will enable us to actually load various image file formats like JPEG, PNG, TIFF, etc. from disk via the cv2.imread function. If you don't install these, you won't be able to load various image file formats from disk, and it'll leave you scratching your head and wondering why the function is returning none on load. So make sure these are installed, otherwise you'll get none type errors when loading an image from disk. I'm going to let these finish up installing, and then we can move on to the video I/O packages right here. Again, just as we have image I/O packages, we have video I/O packages. These allow you to read various video file formats from disk. So I'm going to go ahead and install these. Again, make note that it's actually 2 lines of commands. This first one up here. So do this one first, and then when it completes, you can move down here, copy and paste the command into your terminal, and let that install as well. So I'm going to do that real quick, and then from there we can move on to all of our GUI modules and packages. OpenCV has a submodule named HiGUI, and it's responsible for allowing us to build and display simple GUIs to our screen. Most importantly is the cv2.imShow function. This actually displays the video or image to your screen. If you don't have GTK installed, you won't be able to see any type of windows displayed to your screen via OpenCV. So make sure you do not forget this step. It's very important, especially if you want to use any of the cv2.imShow and cv2.wakeKey functions. This is a larger package. It's going to take about a minute or so to install. So I'm going to let this run, and once it's finished, I'll check back in with you. Welcome back. GTK has successfully installed, so we're going to move on to our next command. These packages are used for optimizing various routines inside of OpenCV, mostly matrix operations. Make sure you install these so you can really optimize OpenCV and make sure it runs well on your Raspberry Pi. So we'll go ahead and wait a few seconds for these packages to get installed, and we'll then move on to installing our Python 2.7 and Python 3 header files. We need these header files to ensure that we can actually compile our OpenCV to Python bindings. So go ahead and copy and paste this command into the terminal now, and we'll let this install as well. So let's go ahead and move on to actually downloading the OpenCV source code. I'm going to assume you're in your home directory, cd tilde, so that'll put you right back in your home directory, and then you can use wget to actually download the source code files. We'll be using OpenCV 3.3.0 for this blog post, so make sure you download that file, and you'll want to make sure that this version file matches up with this version for the contrib repository as well. Otherwise, your compile will fail. So I'm going to go ahead and unzip the opencv.zip file while we talk a little bit more about version numbers. So again, I mentioned 3.3.0 is the OpenCV version number we'll be using for this blog post. In the future, you'll see new OpenCV version numbers such as 3.4, 3.5, etc. You can still use this tutorial without a problem. So just make sure you update the corresponding version numbers in your wget commands as well. We'll see, coming back to our terminal, we see that the opencv.zip file has been inflated. So let's also grab the opencv_contrib library as well. You want to install OpenCV contrib so you can have access to additional features such as sift and surf. These are not included by default in OpenCV 3. They were in OpenCV 2.4, but not OpenCV 3. So you want to make sure you actually download the contrib file as well and unzip it. So let's wait a few seconds for this to finish up, and we can move on to actually setting up our Python 2.7 and Python 3 build. So at this point, you really need to start considering which Python version do I want to use, Python 2.7 or Python 3. To be honest with you, I would recommend Python 3 at this point. It certainly is the future of Python. Python 2.7 will stop receiving updates in the near future, so you might as well start getting used to Python 3 now. In terms of performance, is Python 2.7 faster than Python 3 or vice versa? In the context of computer vision and OpenCV, you're not going to notice a real difference. So don't let the speed or performance be a deciding factor for you. Just choose whichever Python version you're most comfortable with and go from there. Again, keeping in mind that Python 3 will be the future of Python, so I do recommend you start getting comfortable with it now. We need to install pip, a Python package manager. So all we need to do is download the git pip script, and we can install it for both Python 2.7 using this command. That'll just take a few seconds to install, and then once it finishes up, we'll also install it for Python 3 as well. So let's do this for Python 3 just to make sure everything is configured properly, and then we can move on to installing Virtualenv and Virtualenv wrapper. I highly recommend you use these Python packages. They allow you to create separate, sequestered, independent virtual environments for each of your projects. It's really a standard best practice in the Python community that whenever you start a new project, launch up a new virtual environment and ensure that you don't run into basically dependency hell where you run into a bunch of conflicts. Virtual environments solve all of that for you, meaning you can have different versions of different libraries installed in different virtual environments, and none of them conflict with each other. It's a really excellent tool, and again, it's a standard best practice that I highly recommend you do. We can actually install both Virtualenv and Virtualenv wrapper using pip. Just a simple copy and paste. So I will paste that into the terminal now and let it install. So only take a couple seconds. Now that Virtualenv and Virtualenv wrapper are installed, I recommend deleting your cache directory for pip. Sometimes you'll run into permission errors when running sudo. Again, it's optional, and you may not even run into any issues, but just go ahead and do that to be safe. So we have Virtualenv and Virtualenv wrapper installed on our system, but we actually need to update our profile file. It's actually a hidden file in our home directory. And we want to insert the following lines at the bottom of the file. I prefer, you can use your favorite text editor for this. You could use Nano, VI, Emacs. I'll just use Nano because it's a really simple editor, even for people who are just getting started. So as you can see, name of the editor is Nano, ~/ dot profile, hit enter. And we'll see there's already some contents in this file. That's okay. Just scroll down to the bottom and copy and paste our commands in here. When you're ready to exit the editor, hit Control X, and it'll ask you to say, do you want to save your changes? And we'll say yes, we certainly do want to save our changes. Hit the Y key and then enter. That will enable the file to be written and updated to our disk. So anytime we launch a terminal, we log into our Pi, this .profile file should be automatically loaded for us. Since we're already logged in, we need to manually type source profile so we can reload the contents of it. What you could also do is log out of your SSH connection, log back in. You could open up a new terminal if you have your keyboard and mouse and monitor hooked up, or you could just simply run the source command. I think running the source command is easiest, but whichever one is easier for you, you should do that. So let's go ahead and move on to creating our Python virtual environment. I'm going to use Python 3 for this example. If you wanted to use Python 2, you would simply use this command. But for Python 3, just copy and paste the make virtual environment command in here. The -p indicates our Python version. Again, this is Python 3, and I'll be creating a virtual environment named CV. CV for computer vision. Again, I want to mention that this virtual environment is totally independent and separate from the Python install on our Raspberry Pi. So any libraries that we install into the virtual environment will not affect the system install of Python at all. This is a great tool and again, a best practice in the Python community. So before we get too far, I just want to again mention how you can check if you're in the CV virtual environment. Notice how my prompt here has the 2 characters CV in parentheses. This indicates that I am actually inside the CV virtual environment. If I were to log out of my Pi and then log back in, you would see that there is no CV in front of my prompt. This implies that I am not in the CV virtual environment. If you were to log out from your Pi, load up a new terminal, re-log in via SSH, you'll absolutely 100% need to access your virtual environment again to access any OpenCV bindings once we get around to compiling them. To do that, it's just a simple source, just as we did before, and then this will ensure our Virtualenv and Virtualenv wrapper commands are available to us, and then just type on work on CV, and this will go ahead and drop us into the CV virtual environment. So there you can see it right here, CV inside the virtual environment. If you wanted to leave a virtual environment, you would just type deactivate, and that'll pop us out of the virtual environment. And to come back in, again, just work on CV, and we're back inside. Right, let's continue on with our tutorial. The only dependency we need when installing OpenCV on our Raspberry Pi is Numpy. So we just need to copy and paste it, pip install Numpy. Again, we're installing it into the CV virtual environment. So let's go ahead and get that installed. It probably is going to take 10 to 15 minutes to get Numpy installed. I would recommend going for a short little walk, making yourself a cup of coffee or a cup of tea, and just waiting for the install to finish up. So a question I often get asked is, help, my Numpy installation is hung, nothing's happening, it's not installing. Actually, it is installing, and you can configure this if you were to look at the CPU usage of your Raspberry Pi. The Raspberry Pi is not as fast as your laptop or desktop. It will take some time to get this package installed. Again, approximately 10 to 15 minutes. So I'm going to let my Pi chew on the installation a little bit, and once it's finished back up, I'll check in with you again, and we'll continue compiling, installing OpenCV for Raspbian Stretch. Welcome back. As you can see from my terminal output that Numpy 1.13.1 has been installed. If you actually want to verify this for yourself, you can just run the pip freeze command, and it'll print out all packages that are installed in your environment. And sure enough, we have Numpy there. So we can safely proceed to step number 5, where we actually compile and install OpenCV. Again, I really want to make sure that you're in the CV virtual environment before executing any make or cmake configuration commands to start to configure and build your compile. If you're not inside the CV virtual environment, you'll run into problems with compile. Either it fails to compile or it fails at import time. So make sure you run work on CV and verify that you're in the CV virtual environment, as I am here. So what we're going to do is change directory to our home directory, subdirectory OpenCV 3.3.0. This will be where this is where the source code for OpenCV lives and where our build is going to take place. So let's make the build directory, change directory into the build folder, and we're just going to copy and paste this command right here. This is our cmake command, and it actually configures our build. So just copy and paste it and hit enter to execute it. And this command will go through our Raspberry Pi, check for certain libraries, set paths, check our Python versions, ensure Numpy is installed, and it'll spit back a configuration that we can use to actually compile OpenCV. This configuration is going to take a couple minutes, so I'm going to go ahead and let this run, and I'll get back to you once the configuration is finished. Welcome back. CMake has just configured our OpenCV build, so let's go ahead and inspect the output and make sure everything is configured properly. If you're using Python 2.7, you'll want to scroll through your CMake output and look for the Python 2.7 section. Again, I'm assuming you're using the CV virtual environment, so you want to make sure your interpreter, your libraries, your Numpy and packages paths are all configured properly and set. So if you're using Python 2, check this section here. We're using Python 3, so we're actually going to check this section right here. And notice how my interpreter is set to CV right here in the virtual environments directory. The library is properly set for Python 3.5. Numpy is being used from within the CV virtual environment. And finally, this is the site packages directory for Python 3.5. Check these outputs whether you're using Python 2 or Python 3. In particular, you want to make sure your interpreter and your Numpy path is set properly. This should be automatically set provided you're in the CV virtual environment. So again, there's nothing you need to manually configure. Just again, make sure you're in that CV virtual environment, and CMake will be able to take care of the rest for you. We are now ready finally to compile OpenCV. All I need to do now is type in make, and this will kick off the compile process. When I ran the compile on my system, it took approximately 4 hours to install, which is quite long and a bit frustrating, especially with Raspbian Jessie, where I could get everything compiled and installed in about a little over an hour. And the reason is because I was able to use the J2 and J4 switches, meaning we're going to compile with multiple cores on our Raspberry Pi. That make-J2 will use 2 cores, make-J4 will use 4 cores. Every time I tried to use either of these commands with Raspbian Stretch, Raspberry Pi would overheat, possible race conditions going on with the compile. Not really sure what the underlying issue is, but it has only happened with Raspbian Stretch, not with Jessie or Wheezy. So I'm not sure what the exact issue is there. However, you can still get OpenCV compiled and installed on Stretch. You just need to use make using only 1 core. The downside, of course, is it's going to take a lot longer to compile. So I'm going to go ahead and let OpenCV compile on my system. Once it's finished in about 4 hours or so, we'll come back and finish up the install. Again, go for a walk, maybe even let this run overnight while you're asleep, and when you get back, OpenCV should be all compiled and we can finish this up. Well, it's been about 4 hours, but as you can see from my terminal output, OpenCV3 has successfully been compiled. So next step is to just run sudo make install, and this will copy the respective files into their locations across the operating system. This will take about a minute to run, so I'm going to let this finish up and we'll meet back here once the install is finished. All right, just one final command and our install will be done. However, there are just 1 or 2 more steps we need to do depending whether you're using Python 2.7 or Python 3. And we'll go into those right now. So I'm going to change directory back to my home directory, and if I list the contents of user local lib python 2.7/site packages, you'll see there's nothing in this directory. And that's because we compiled our OpenCV and Python bindings for Python 3. If you configured CMake to use Python 2.7, you would find a file named cv2.so in this directory. Since we use Python 3.5, we need to go back and change our directory here. And sure enough, you'll see this this file. These are our OpenCV bindings. I don't know exactly why CMake and make do this for the Python 3 bindings, but they generate this cython-35m-arm-linux.so file. It should just be cv2.so. But luckily, that's an easy fix. All we have to do is rename the file. So I'm going to change directory to my Python 3.5/site packages directory, move this to cv2.so, and now that's done. Oops, I have to use sudo for the proper permissions. There we go. The last step is to simply create a symbolic link for our cv2.so files in our Python virtual environment. So if you remember, my virtual environment name was cv. So we're going to change directory into the site packages directory for the virtual environment and create a symlink between those on our compiled cv2.so bindings, and put them in the site packages directory like so. Again, if you were using Python 2.7, you would do these exact same steps, only instead you would use these commands right here. Since we're using Python 3.5, we had to use these commands here. Our last step is to simply change directory back to our home directory, source our .profile as such, and then we're going to access our CV virtual environment via the work on command. And here's the moment of truth. What we're going to do now is fire up our Python shell inside of our virtual environment and try to import the OpenCV bindings. We'll see if this works. And sure enough, there's no error message. And just to confirm, we'll check out our version. And sure enough, OpenCV 3.3 is installed for Python 3.5. And of course, if you use Python 2.7, you would see the exact same output just for the Python 2.7 binary. If you had any issues with your install, I would highly suggest that you check out the troubleshooting and frequently asked section of this blog post. The vast majority of problems that you'll run into when installing OpenCV are covered in this section. So I just want to say congratulations on getting OpenCV up and running on your Raspberry Pi. If you're looking for your next step, I would definitely suggest that you take a look at my book, Practical Python and OpenCV. All code examples in this book are 100% compatible with the Raspberry Pi. You'll learn how to do face detection in images, object tracking in video, handwriting recognition, and even build systems that can identify objects, such as recognizing the covers of books. If you ran into other issues installing OpenCV on your Raspberry Pi, definitely take a look at the Quick Start bundle and the hard copy bundle of my book. Both of these bundles contain a pre-configured Raspbian.image file. You just download the image file, flash it to your SD card, and boot. OpenCV is pre-configured and pre-installed on it. It's by far the fastest way to get it up and running with OpenCV on your Raspberry Pi. So thank you again for working through this tutorial with me. I'll see you later.